September 7th, 1942, 6:47 a.m., Willow Run, Michigan. The smell of wet concrete and fresh-cut lumber filled the air as Rosie McKnight, a 19-year-old farm girl from Ypsilanti, stared at the blueprint taped to her workstation. Sheet Metal Assembly, Station 47, Section B4. The diagram showed 47 individual aluminum panels that would form part of a B-24 Liberator's wing section. Each panel required 312 rivets, installed in a specific sequence, with tolerances measured in thousandths of an inch. 3 weeks ago, Rosie had been driving a tractor on her father's dairy farm. She had never seen an airplane up close. She had never held a rivet gun. She had never worked with metal of any kind. Now she was responsible for assembling components that would carry 10 men through flak-filled skies over Germany at 25,000 feet, where a single structural failure meant death for the entire crew. Around her, the largest manufacturing facility ever built stretched for over a mile. The Willow Run plant, constructed in just 18 months on farmland Henry Ford had purchased for $1, covered 3.5 million square feet under one roof. The assembly line extended 2,400 feet, longer than 4 city blocks. At the far end of the building, a completed B-24 Liberator rolled off the line every 63 minutes. 4-engine heavy bombers, each containing 1,550,000 individual parts, were manufactured by workers who had never built aircraft before, using techniques that didn't exist when construction began. What the German High Command didn't know, what they couldn't have imagined, was that America's greatest weapon wasn't technology or firepower. It was the farm girl from Ypsilanti, the mechanic from Detroit, the welder from Pittsburgh, the riveter from California. People who had grown up fixing tractors, building barns, and welding farm equipment. People who understood machinery, precision, and hard work. People who would transform American industrial capacity from a theoretical possibility into a crushing reality. The mathematics of defeat were being calculated not in combat, but in production. Every 63 minutes, another bomber. Every hour, another weapon that would carry the war to Germany's industrial heart. The assembly line at Willow Run would produce more heavy bombers than the entire German aircraft industry combined. And it was staffed primarily by people who, months earlier, had been growing corn and milking cows. This is the story of how farmers built the bombers that won the war, how American agricultural know-how translated directly into industrial dominance, how people who had never touched an airplane created the air armada that destroyed Nazi Germany's ability to wage war. The transformation began not with engineers or factory workers, but with a realization that would reshape global warfare forever. The same skills that built a barn could build a bomber. The B-24 Liberator had emerged from a 1938 requirement for a heavy bomber with longer range and higher payload than the B-17 Flying Fortress. Consolidated Aircraft's chief designer, Isaac M. Ladden, created a revolutionary design incorporating a high aspect ratio Davis wing that provided an exceptional lift-to-drag ratio, twin vertical stabilizers for stability, and a tricycle landing gear that made ground handling easier. The prototype XB-24 first flew on December 29, 1939. It was faster than the B-17, could carry more bombs, and had a greater range. But it was also more complex to manufacture, requiring more precision assembly and tighter tolerances. Each B-24 required 313,327 separate parts, excluding rivets, bolts, and fasteners. The wing alone contained 66,239 parts. The fuel system included 3,614 components. The electrical system comprised 2,847 individual pieces. Building 1 required the coordination of thousands of subcontractors, producing components to specifications measured in 10,000ths of an inch. It required assembly workers who could read complex blueprints, operate precision tools, and maintain quality standards that exceeded peacetime manufacturing. It required a level of industrial organization that most experts believed was impossible to achieve. The Army Air Forces ordered 1,174 B-24s in 1940, before the prototype had completed testing. Then Pearl Harbor happened. The order increased to 9,738, then 18,482, then 24,000. The numbers became almost meaningless. America was ordering bombers faster than factories could be built to produce them. The solution was Willow Run, Henry Ford's audacious answer to an impossible problem. Ford, 78 years old in 1941, believed that aircraft could be mass-produced using automobile assembly line techniques. The aviation industry, protective of its specialized manufacturing methods, insisted it couldn't be done. Aircraft were handcrafted, they argued. Each one was unique. Mass production would compromise quality and safety. Ford ignored them. In April 1941, Ford Motor Company signed a contract to produce B-24s using assembly line methods adapted from automobile manufacturing. They would build the largest factory in history, develop entirely new production techniques, and train workers with no aircraft experience to build bombers. The experts predicted catastrophic failure. Ford predicted 1 bomber per hour within 2 years. Construction began on April 18, 1941. The site, a 975-acre plot of farmland in Ypsilanti Township, was nothing but fields and a few farmhouses. Within weeks, 10,000 workers descended on the property. They poured 3,500,000 cubic yards of concrete for the foundation, enough to build a highway from Detroit to Cleveland. They erected 13,000 steel columns supporting a roof that covered 67 acres. They installed 1,600 machine tools, 7,500 jigs and fixtures, and 1,074 overhead cranes. The scale defied comprehension. The main assembly bay alone was longer than the Chrysler Building was tall. The L-shaped building enclosed more floor space than 280 football fields. The ventilation system moved 2.5 million cubic feet of air per minute. The electrical system consumed enough power to supply a city of 100,000 people. But the building was just infrastructure. The real challenge was the workforce. Ford needed 42,000 workers to operate the plant at full capacity. They needed to be trained from scratch in aircraft assembly techniques, and they needed to achieve quality standards that experienced aircraft workers struggled to maintain. The first workers arrived in June 1941. Many came from farms in Michigan, Ohio, Indiana, and Illinois. They knew machinery, but farm machinery: tractors, combines, hay balers, and milking equipment. Machines that were built to tolerances measured in 30 seconds of an inch, not thousandths. Machines that could be fixed with a hammer and wire if necessary, not precision instruments requiring micrometer measurements. William Cunson, former General Motors president and head of the Office of Production Management, visited Willow Run in August 1941. His assessment, recorded in a memo to President Roosevelt, was cautiously optimistic. Ford's approach is revolutionary. If it works, aircraft production will increase tenfold. If it fails, we will have wasted critical time and resources. The outcome depends entirely on whether farm workers and former automobile employees can be trained to aircraft quality standards. The training program began in September 1941, 3 months before Pearl Harbor. Workers attended 8-hour classroom sessions, learning blueprint reading, precision measurement, and quality control. They practiced on mock-up sections, installing rivets until they could achieve perfect alignment blindfolded. They learned that a rivet installed at the wrong angle could create a stress point that would cause structural failure at altitude. A gap between panels measured in thousandths of an inch could create turbulence that reduces range. That every component mattered because failure meant death. Rosie McKnight, the farm girl from Ypsilanti, attended training in October 1941. Her instructor, a former Consolidated Aircraft supervisor from San Diego, was skeptical. In a letter to a colleague discovered decades later, he wrote, "These farm kids have good hands and understand machinery, but they have no concept of precision work. Today I watched a girl try to measure panel thickness with a micrometer. She handled it like a wrench. It will take months to train them properly, if it's even possible." That instructor's name was Thomas Henderson. 3 months later, in January 1942, he would write a follow-up letter. "I was wrong about the farm workers. They learn faster than experienced factory workers because they have no bad habits to unlearn. They understand cause and effect from years of maintaining machinery. Show them why a rivet must be installed at a specific angle and they remember it. They ask questions that experienced workers never think to ask. Yesterday, a girl from a dairy farm noticed that the rivet pattern on the tail section created an asymmetric stress distribution. She was right. The engineering team adjusted the design." The transformation from farmhand to aircraft assembler happened faster than anyone predicted. Workers who had spent their lives repairing equipment by feel learned to trust precision instruments. Farm girls who had never held tools more sophisticated than wrenches became experts with micrometers, calipers, and dial indicators. Men who had built barns learned to read blueprints showing stress calculations and aerodynamic load distributions. By December 1941, Willow Run employed 8,000 workers. The first B-24 components were being assembled, though at a pace that would need to increase 100-fold to meet production targets. Then came Pearl Harbor. December 7, 1941, changed everything. The attack that destroyed much of America's Pacific Fleet created a sense of urgency that transformed Willow Run from an experimental facility into a crusade. Workers began volunteering for double shifts. Training time compressed from weeks to days. Quality control inspectors, terrified of passing defective components that might kill American air crews, rejected parts at rates exceeding 40%, slowing production but ensuring integrity. The first complete B-24 emerged from Willow Run on September 10, 1942, 16 months after groundbreaking. It had taken 300,000 man-hours to build. The production target was 1 aircraft per hour, which would require reducing assembly time to 63 man-hours per plane. Nobody believed it was possible. Charles Sorensen, Ford's production manager, implemented techniques that would revolutionize aircraft manufacturing. Instead of building complete aircraft in one location, with workers moving between stations, he created a true assembly line where the aircraft moved and workers stayed at fixed positions. Each station performed specific tasks repeated identically on every aircraft that passed. Station 12. Install main wing spar, secure with 847 bolts torqued to 125 foot-pounds. Time allowed, 8 minutes. Station 23. Install fuel tanks, connect fuel lines, and test for leaks. Time allowed, 12 minutes. Station 47. Install wing skin panels, 312 rivets per panel, 6 panels per station. Time allowed, 15 minutes. The precision required was unprecedented. Rosie McKnight, now a team lead at Station 47, supervised 6 workers installing wing panels. Each rivet had to be driven to exact specifications. Too shallow and it wouldn't hold. Too deep and it compromised the aluminum's structural integrity. The rivet gun's pressure, the angle of installation, and the backup pressure from the bucking bar on the opposite side all had to be perfect. Her team developed a rhythm. First worker positioned the panel, checking alignment with 3 measurement points. The second worker drilled pilot holes. The third and fourth workers installed rivets, one on each side. The fifth worker inspected with a mirror and flashlight, checking for gaps. The sixth worker stamped the quality control approval. 15 minutes, start to finish, repeated every time an aircraft reached its station. The reject rate at Station 47 started at 67%. Too many rivets installed incorrectly, panels misaligned, gaps exceeding tolerance. Rosie's supervisor, a Ford production engineer, told her the station would be shut down if quality didn't improve. She gathered her team during a shift break. "We're farmers," she told them, according to a diary entry discovered in 1993. "We know how to do things right because we know what happens when we don't. A bad rivet is like a broken fence rail. Doesn't fail immediately, but it fails when stress hits. We're building fences that have to hold at 25,000 feet with men's lives depending on them. We do it right or we don't do it at all." The reject rate at Station 47 dropped to 12% within 2 weeks, then to 3%, then below 1%. The station became a model for training other teams. Rosie McKnight, the farm girl who had never touched an aeroplane, was promoted to training supervisor in March 1943. She would personally train over 2,000 workers in wing assembly techniques. But wings were just one component. The fuselage presented different challenges. The B-24's distinctive twin tail design required complex aluminum forming and precise structural assembly. The nose section, where the bombardier and navigator sat, featured a clear plexiglass assembly containing 38 individual panels, each formed to specific curves, sealed with rubber gaskets that had to remain airtight at 40 below zero. James Morrison, a 54-year-old farmer from Howell, Michigan, supervised fuselage assembly at Station 34. He had built barns for 30 years, understanding structural loads, weight distribution, and stress points instinctively. When Ford's engineers showed him blueprints for the fuselage frame, he immediately identified a potential problem. "This crossmember here," he pointed to a structural element in the aft fuselage, "takes compression load from the tail, right? But you've got the support gusset on the wrong side. When the tail takes a vertical stress, that gusset's going to create a moment arm that twists the whole frame. Seen the same thing happen on a barn when the builder put the support beam on the wrong side of the rafter." The engineers, graduates of MIT and Caltech, were skeptical. The design had been tested by Consolidated Aircraft's stress analysis team, but they ran the calculations again considering Morrison's point. He was correct. Under certain loading conditions, the gusset placement would create torsional stress that could cause structural failure. The design was modified, adding a secondary support that eliminated the problem. Morrison's barn building experience had identified a flaw that aerospace engineers had missed. It wasn't the last time. Farm workers throughout Willow Run contributed practical insights that improved the B-24's design. They understood machinery, loads, stress, and structural integrity from years of building and maintaining equipment under real-world conditions. By June 1943, Willow Run was producing 150 B-24s per month, still far short of the 1-per-hour target, but improving steadily. The workforce had grown to 34,000, working 3 shifts around the clock. The factory never stopped. Bombers moved down the line 24 hours a day, 7 days a week. The logistics were staggering. Each B-24 required components from 18,000 suppliers scattered across 48 states. Pratt & Whitney engines from Connecticut, Hamilton Standard propellers from Massachusetts, Sperry bomb sights from New York. Consolidated produced the wing center section at its Fort Worth plant and shipped it to Michigan by rail. Every component had to arrive precisely when needed, since Willow Run had no storage space. The rail yard adjacent to the factory handled 1,600 freight cars daily, delivering 5,000 tons of components. Trucks departed every 90 seconds, carrying completed bombers to the airfield 3 miles away, where test pilots would conduct first flights. The entire system operated with precision that exceeded Swiss watchmaking, coordinated by workers who had been farming 18 months earlier. Martha Wilson, a 43-year-old widow from a farm outside Ann Arbor, managed inventory control for Section C, responsible for tracking 12,487 different part numbers and ensuring each arrived at the correct station at the correct time. She had managed her farm's accounts, tracked crop yields, and coordinated harvest schedules involving dozens of workers and multiple pieces of equipment. The skills translated directly. Farming teaches you to think 3 steps ahead. You don't plant corn the day you want to harvest it. You plan months in advance, account for weather, coordinate equipment, and manage people. Here, I'm doing the same thing. These parts are the seeds. The bombers are the harvest. I make sure everything arrives when needed. Nothing too early to waste storage space, nothing too late to stop the line. Her section achieved a 99.7% on-time delivery rate, the highest in the facility. When Ford's production engineers asked how she maintained such accuracy, she showed them the system she'd developed, a modified version of crop rotation planning adapted for industrial components. The system was implemented throughout Willow Run, improving overall efficiency by 23%. But efficiency meant nothing if quality suffered. The Army Air Forces maintained strict inspection standards. Each completed B-24 underwent 1,847 separate inspections before acceptance. Any failure meant the aircraft was pulled off the line for correction. In early 1943, the rejection rate exceeded 18%, a catastrophic failure that threatened the entire program. Colonel William Draper, Army Air Forces Inspector General, arrived at Willow Run in March 1943. His preliminary report, later declassified, was scathing. Production numbers are impressive but meaningless if aircraft fail inspection. Current quality levels are unacceptable for combat operations. Recommend immediate improvement or contract termination. Henry Ford, facing the greatest crisis of his manufacturing career, didn't argue. He implemented a radical solution. Every worker would personally sign off on their work. A small metal tag stamped with the worker's employee number would be attached to every component they assembled. If that component failed inspection, the worker's entire team would be held accountable. The announcement caused uproar. Workers feared they would be fired for honest mistakes. Union representatives protested that the policy was punitive and unfair. Ford was unmoved. "If you're not willing to put your name on it," he told assembled workers in April 1943, "these aircraft will carry American boys into combat. Your name is your promise that you built it right." The policy was implemented in May 1943. The psychological effect was immediate and profound. Workers who had been anonymous members of an assembly line suddenly felt personal responsibility for the aircraft they built. Rosie McKnight began inspecting every rivet her team installed, not just spot checking. James Morrison personally tested every structural joint in the fuselages that his section assembled. Martha Wilson triple-checked part numbers before releasing components to the line. The rejection rate plummeted to 4% within 6 weeks, then to 1.2% by August. Quality inspectors reported that defects requiring correction had decreased by 87%. Workers were building better aircraft because they knew their name was literally attached to their work. But personal accountability couldn't solve every problem. The B-24 remained a complex aircraft requiring precision assembly that pushed the limits of mass production. The nose turret, containing 2.50 caliber machine guns in a rotating mount, required 847 parts assembled in a specific sequence, with tolerances of 0.003 of an inch. A single misaligned component could jam the turret, rendering it useless in combat. Eleanor Harrison, a 26-year-old farm girl from Ohio who had operated a corn picker on her family's farm, assembled nose turrets at Station 52. The work required extraordinary precision and patience. Each turret took 4.5 hours to assemble, even with 3 workers collaborating. She discovered that her corn picker experience translated directly to turret assembly. The corn picker had rotating blades that had to align perfectly with the feed mechanism, she explained in a 1987 oral history interview. If the alignment was off by even a little bit, the whole machine jammed. The turret was the same principle. Everything had to rotate smoothly with no binding. I used the same troubleshooting approach I used on the corn picker. Check clearances, test rotation at each step, verify nothing was creating friction. Her section achieved the lowest turret failure rate in the facility. Army Air Force's inspectors, examining completed aircraft from Willow Run, consistently noted that turrets assembled at Station 52 operated more smoothly than those from any other source, including Consolidated's own San Diego plant. This pattern repeated throughout Willow Run. Farm workers applying agricultural machinery experience to aircraft assembly often achieved better results than trained aircraft workers. The reason, production analysts concluded, was that farmers understood machines as systems, not just collections of parts. They thought about how components interacted, how stress transferred through structures, and how failures propagated through mechanisms. By September 1943, Willow Run was producing 365 B-24s per month, approaching the 1 per hour target that experts had declared impossible. The workforce peaked at 42,331 workers, of whom 14,477 were women, many from farm backgrounds. The facility operated with efficiency that exceeded Henry Ford's most optimistic projections. But numbers alone don't capture the human reality of building bombers at such a scale. The workers at Willow Run weren't just assembling aircraft, they were building weapons that would carry war to Germany's industrial heartland. They knew that every bomber they produced would face flak over Berlin, fighters over the Ruhr, and weather over the North Atlantic. They knew that some would be shot down, their crews killed or captured. This knowledge weighed heavily. Dorothy McMaster, a riveter from a farm near Battle Creek, kept a journal throughout her time at Willow Run. An entry from November 1943, discovered by her granddaughter in 2004, reveals the emotional complexity. Today we finished bomber number 4847. I riveted the navigator's compartment, the place where a young man will sit and guide his crew to the target. I thought about my brother Charles navigating B-17s over Germany. I wondered if the crew flying this bomber has a sister somewhere, riveting another aircraft, thinking of them. We're connected, all of us, building machines that will save some boys and doom others. The weight of it sometimes makes my hands shake, but I drive the rivets true, because that's all I can do. Build it right. Give them the best chance. The emotional burden intensified when news arrived of aircraft losses. On August 1, 1943, B-24s from the 9th Air Forces attacked Romanian oil refineries at Ploiești in one of the war's costliest bomber missions. Of 177 B-24s that reached the target, 54 were shot down. Another 58 were damaged. The losses represented roughly 1/3 of the attacking force. When news reached Willow Run, production stopped for 15 minutes while workers held an impromptu memorial. Then they returned to work, grimly determined to build replacements. Production that month reached 387 bombers, the highest monthly total yet achieved. The connection between factory workers and combat crews became personal in unexpected ways. The Army Air Forces began arranging visits where bomber crews would tour Willow Run, meeting the people who built their aircraft. In March 1944, the crew of Chute Luke, a B-24 that had completed 47 combat missions over Europe, visited the factory. The aircraft's commander, Captain Robert Patterson, spoke to assembled workers. Chute Luke has been hit by flak 238 times. She's been attacked by fighters, lost 2 engines over Stuttgart, and crash-landed in England with no hydraulics. But she brought us home every time. That's because of you. The rivets you installed, the welds you made, the components you assembled. You saved our lives 47 times. We came here to say thank you. The entire factory floor erupted in applause. Workers who had been anonymous parts of a vast industrial machine suddenly understood their direct connection to the boys fighting over Europe. Rosie McKnight, standing near the visiting crew, wrote in her diary that night, "Saw the boys who fly the planes we build. They're so young, younger than me. They thanked us for keeping them alive. Tomorrow I'll reflect with that thought in my mind. Every rivet is a promise to bring them home." Production intensity increased through late 1943 and into 1944. The factory operated at a capacity rarely seen in peacetime manufacturing. The assembly line moved continuously, bombers progressing through 1,547 individual workstations, each performing specific tasks in exact sequences. The noise was deafening. Hundreds of rivet guns hammering simultaneously created a constant metallic thunder. The smell of cutting oil, aluminum filings, and aviation fuel permeated everything. The temperature varied wildly, from freezing near the massive doors where aircraft exited to sweltering near the welding stations where workers assembled engine mounts. Yet productivity continued climbing. In March 1944, Willow Run produced 453 B-24s, achieving the 1-per-hour target for the first time. The accomplishment meant that every 63 minutes, a complete 4-engine bomber weighing 36,500 pounds empty, containing 1,550,000 parts, rolled off the line ready for flight testing. Henry Ford, 80 years old and in declining health, visited the factory in April 1944 to witness the achievement. According to witnesses, he walked the length of the assembly line in silence, watching farmers-turned-assemblers build bombers with precision that would have been impossible to imagine 3 years earlier. His only comment, recorded by Charles Sorensen, was, "I always knew Americans could build anything if you gave them the right tools and showed them why it mattered. These people aren't just building bombers, they're building victory." But the human cost of maintaining such production was severe. Workers averaged 54 hours per week, often working 6 or 7 consecutive days. Injuries were common despite safety protocols. The mental strain of maintaining precision while working at such pace caused breakdowns. Absenteeism due to exhaustion reached 9% in May 1944, forcing Ford to implement mandatory rest days. The workforce turnover was equally problematic. Workers left for higher-paying jobs in other defense plants, returned to farming for harvest season, or simply burned out from the relentless pace. Willow Run hired 96,482 workers between 1941 and 1945 to maintain an average workforce of 42,000. The training and integration of new workers while maintaining quality standards required extraordinary management. Sarah Mitchell, a training supervisor who had taught farm kids to drive tractors in Iowa before the war, developed accelerated training programs that reduced new worker orientation from 2 weeks to 3 days. Her method focused on pattern recognition rather than rote memorization. Farmers learn by doing, she explained in training manuals later adopted across the industry. Show them the pattern once, let them practice twice, then put them on the line with supervision. They learn faster under real conditions than in classroom settings. Monitor closely for the first day, spot check the second, and full independence by the third. It works because they're accustomed to taking responsibility quickly. On a farm, you don't get 2 weeks to learn how to fix a broken combine during harvest. You figure it out and fix it. Same here. Her training methods reduced the defect rate among new workers by 61% compared to traditional classroom-based training. By late 1944, Willow Run was integrating 800 new workers monthly while maintaining production above 450 bombers per month. The scale of production created logistical challenges that cascaded through the entire supply chain. Pratt & Whitney, producing R-1830 engines for the B-24, needed to manufacture 1,800 engines monthly just for Willow Run. Each engine contained 3,400 parts machined to tolerances of 1/10,000th of an inch. Hamilton Standard needed to produce 1,800 four-blade propellers monthly, each blade precisely balanced to prevent vibration at 2,700 RPM. The aluminum requirement alone was staggering. Each B-24 contained 17,000 pounds of aluminum formed into 12,000 separate panels, spars, bulkheads, and structural components. At peak production, Willow Run consumed 7.7 million pounds of aluminum monthly, enough to build 30,000 automobiles. This demand rippled through the entire economy. Aluminum production in the United States increased from 412 million pounds in 1940 to 1.95 billion pounds in 1944. New smelters were built across the Pacific Northwest, powered by hydroelectric dams constructed specifically to provide electricity for aluminum production. The entire industrial infrastructure of the nation was reorganized to support bomber production. But while Willow Run grabbed headlines, it wasn't the only facility producing B-24s. Consolidated Aircraft's Fort Worth plant, Douglas Aircraft's Tulsa plant, and North American Aviation's Dallas plant all produced B-24s under license. Together, these facilities would produce 18,482 B-24 Liberators, more than any other American military aircraft in history. The combined workforce exceeded 18,000 people, many from agricultural backgrounds. Farm workers in Texas, Oklahoma, and California applied the same skills that made Willow Run successful. The pattern repeated at every facility. Initially skeptical engineers discovering that farmers understood precision, machinery, and quality control better than expected. Lieutenant Colonel James Doolittle, who led the famous Tokyo raid in 1942, later commanded the 8th Air Force's bomber operations. He addressed the transformation in a 1944 speech to War Production Board officials. The greatest weapon in our arsenal isn't the B-24 or the B-17. It's the American worker who builds them. I've seen farm girls installing engines with precision that would make a Swiss watchmaker jealous. I've seen mechanics who learned their trade fixing tractors now maintaining bombers in combat conditions. They came from fields and farms, and they're beating the Luftwaffe's best by building better aircraft faster than Germany can shoot them down. The combat record proved his point. By D-Day, June 6, 1944, the 8th Air Force operated 1,718 heavy bombers, primarily B-17s and B-24s. The 15th Air Force in Italy operated another 846 heavy bombers. Together, they could launch raids involving over 2,000 bombers escorted by 1,000 fighters carrying 4,000 tons of bombs to targets across Germany. The Luftwaffe, despite fielding technologically advanced fighters like the Me-262, couldn't stop them, not because German aircraft were inferior, but because they were overwhelmed by numbers. For every German fighter destroyed, American factories produced 5 bombers to replace losses. The industrial capacity that built 18,482 B-24s and 12,731 B-17s couldn't be matched by any nation on Earth. German intelligence reports from late 1944, captured after the war, revealed the psychological impact. Oberst Helmut Bode, Luftwaffe intelligence chief, wrote in November 1944, "American bomber production exceeds our ability to inflict losses. They lose 100 bombers in a month and replace them with 400. We destroy 5 in a single raid, and they return the next day with 10 more. This isn't a battle of aircraft quality. It's an industrial avalanche that no amount of tactical brilliance can counter." The avalanche was built by Rosie McKnight, installing rivets, James Morrison, assembling fuselages, Eleanor Harrison, aligning turrets, and tens of thousands of workers who had never imagined they would build the weapons that would win the war. The human cost of this industrial miracle is often forgotten. Between 1942 and 1945, approximately 37,000 workers were seriously injured at aircraft plants to required hospitalization. 487 were killed in industrial accidents. The vast majority were civilians who had volunteered to support the war effort, receiving no combat pay, no medals, no veterans' benefits. Dorothy McMaster, the riveter from Battle Creek, whose journal captured the emotional complexity of bomber production, was killed in December 1944 when a wing panel being moved by an overhead crane broke free and fell 30 feet. She was 24 years old. Her funeral was attended by 300 Willow Run workers who had known her. The bomber she was working on when she died, serial number 4451234, was completed by her shift and dedicated to her memory. It flew 37 combat missions over Germany before the war ended, returning each time safely. The dedication read, "Built by Dorothy McMaster and the workers of Willow Run. May she bring her crews home as Dorothy would have wanted." By January 1945, Willow Run had produced 8,685 B-24s, more than half of all Liberators built. The factory's peak efficiency reached 16.5 aircraft per day, or 1 every 90 minutes around the clock. The transformation from zero production in 1941 to this staggering output in less than 4 years remains one of the great industrial achievements in history. But numbers alone don't capture the significance. What Willow Run proved was that American industrial might wasn't just about factories and machines. It was about people. Farm workers, mechanics, housewives, retirees, all united in a common purpose. Learning skills they never imagined they'd need, building weapons that would determine the outcome of the war. The B-24 Liberator itself was a good bomber, but not a great one. It had quirks. The Davis wing, which provided excellent range, also made it unstable in formation flying. The twin-tail design created blind spots for defensive gunners. The bomb bay doors, which rolled up on tracks, sometimes jammed. Combat crews had mixed opinions about it compared to the B-17. But the B-24's true significance wasn't its combat performance, it was its productivity. The design could be mass-manufactured using assembly line techniques that made production of 18,482 aircraft possible. The B-17, built using more traditional methods, topped out at 12,731 units, despite being in production longer. This productivity meant that by early 1945, the Allies could replace bomber losses faster than Germany could inflict them, a mathematical equation that spelt inevitable defeat for the Luftwaffe. German fighter pilots, no matter how skilled, couldn't shoot down bombers faster than American factories built them. Major Johannes Steinhoff, a Luftwaffe ace with 176 victories, captured this reality in a post-war interview. "We knew by late 1944 that we had lost the industrial war. I could shoot down 5 bombers in a single mission, a good day by any standard. The next day, America would send 10 more. I wasn't fighting pilots anymore. I was fighting factories. And factories don't run out of courage or ammunition. They just keep producing until the war ends. The factories kept producing until Germany surrendered on May 8, 1945. Willow Run's final B-24 rolled off the line on June 28, 1945. The bomber, serial number 445-2400, was accepted by the Army Air Forces but never saw combat. Japan surrendered 6 weeks later. In total, Willow Run operated for 1,158 days, building 8,685 B-24 Liberators. The workforce peaked at 42,331 and averaged 33,000 throughout the war. Of these, approximately 40% were women, and an estimated 60% of all workers had agricultural backgrounds before being hired. They produced one 4-engine heavy bomber every 63 minutes at peak efficiency. That's 16.5 aircraft per day, 115 per week, 500 per month. Each aircraft required 1,550,000 parts assembled to tolerances measured in thousandths of an inch. The reject rate fell from 18% in early 1943 to below 0.5% by war's end. This wasn't just manufacturing, it was the transformation of American agricultural labor into industrial dominance. It proved that skills learned on farms, precision machinery operation, structural understanding, quality consciousness, personal responsibility, translated directly into aircraft manufacturing excellence. The post-war assessment by the War Production Board concluded the Willow Run facility represented the single greatest industrial achievement of the war, not because of technological innovation, but because it proved that American workers, regardless of background, could achieve manufacturing quality and quantity that enemies believed impossible. Rosie McKnight returned to farming after the war, using money she had saved to purchase her own 40-acre farm near Ypsilanti. She never spoke much about her time at Willow Run, considering it simply her contribution to the war effort. When her grandchildren asked decades later how it felt to build bombers, her response was characteristically understated. It was a job that needed doing. We did it right because we knew boys' lives depended on it. That's all. She died in 1998 at age 75. Her obituary mentioned she had worked at Willow Run, but didn't elaborate. At her funeral, a B-24 from the Yankee Air Museum flew overhead, a tribute arranged by her grandchildren. The bomber was one of only 2 flying B-24s remaining from the 18,482 built during the war. James Morrison returned to barn building after the war. His structural designs, influenced by aircraft engineering principles he'd learned at Willow Run, were notably stronger than conventional construction. The barns he built in the late 1940s are still standing today, recognized for their exceptional engineering. He never made the connection explicit, but his family noted that after the war he always signed and dated his work, a practice he'd learned at Willow Run. Eleanor Harrison used skills learned building nose turrets to become a precision machinist, one of the few women to enter that male-dominated field in the 1940s. She worked for General Motors until retiring in 1982, training hundreds of machinists in precision measurement and quality control. Her training manual, still used in some technical schools, emphasizes the importance of understanding how components interact as systems, not just as individual parts. The Willow Run facility itself had an ignominious end. After the war, it was too large to be economically useful. Ford sold it to Kaiser Frazer, which used part of it for automobile production. Later, it housed various industrial tenants. Most of the facility was demolished in 2014, despite efforts by preservationists to save it. A small section remains, converted into a museum dedicated to the workers who built the bombers. But the legacy extends far beyond one building. The techniques developed at Willow Run revolutionized manufacturing. The integration of assembly line methods into aircraft production, initially dismissed as impossible, became standard industry practice. The training methods that transformed farm workers into precision assemblers influenced vocational education for decades. Most significantly, Willow Run proved that American industrial capacity, when fully mobilized, exceeded anything the world had ever seen. The facility that had seemed impossibly ambitious in 1941 became just one of dozens, producing weapons at a scale that overwhelmed the Axis powers. The final statistics capture the magnitude. Total B-24 Liberators produced 18,482 aircraft. Willow Run production 8,685 aircraft, 47% of total. Peak monthly production, March 1945, 505 aircraft. Average production time at peak, 63 minutes per aircraft. Workforce at peak, 42,331 workers. Women in the workforce, approximately 17,000, 40%. Workers with agricultural backgrounds, estimated 25,000, 60%. Parts per aircraft, 1,550,000. Rivets per aircraft, approximately 360,000. Aluminum per aircraft, 17,000 pounds. Maximum monthly aluminum consumption, 7.7 million pounds. Total aluminum used, 296 million pounds, 148,000 tons. Combat sorties flown by B-24s, approximately 226,000. Bombs dropped by B-24s, 452,508 tons. B-24s lost in combat, 3,626 aircraft. Enemy aircraft destroyed by B-24 gunners, 2,600 plus confirmed. Behind each statistic were people who had been farming, who had learned to build bombers from scratch, who worked 60-hour weeks for years, who took pride in their work because lives depended on it. The story of American bomber production is often told as a story of industrial might. It was that, certainly. But more fundamentally, it was a story of people transforming themselves to meet a challenge that had seemed impossible. Farm workers becoming precision assemblers. Barn builders understand aerospace engineering. Tractor mechanics maintained four-engine bombers. They didn't do it for glory or recognition. Most didn't even consider it remarkable. It was simply what needed to be done. The war required bombers. They built bombers. The work required precision. They learned precision. The mission required sacrifice. They sacrificed. In doing so, they created an industrial accomplishment that enemies couldn't match and couldn't comprehend. German intelligence, analyzing American production capacity, consistently concluded that the numbers had to be propaganda. No nation could produce bombers at such rates while maintaining quality. The numbers had to be exaggerated. They weren't. If anything, official statistics understated the achievement. The 18,482 B-24s produced represented only the aircraft that passed final inspection. Thousands more were built but rejected for quality issues, stripped for parts and rebuilt. The true number of aircraft that moved through assembly lines exceeded 20,000. Everyone was built by someone who 3 years ago had been doing something completely different. Someone who had learned skills they never imagined needing. Someone who understood that precision mattered because lives depended on it. The B-24 Liberator wasn't the best bomber of World War II. That distinction probably belongs to the B-29 Superfortress, with its pressurized cabin, remote-controlled guns, and sophisticated fire control systems. The B-24 was simply the most produced American military aircraft in history, built by people who proved that American strength came not from professional soldiers or career engineers, but from ordinary citizens who could transform themselves into whatever the nation needed. Rosie McKnight, installing rivets with tolerances measured in thousandths of an inch, was more representative of American power than any general or admiral. She and tens of thousands like her didn't just build bombers, they built the industrial foundation that won the war. The farmers who built the bombers rarely spoke about their contribution. They didn't consider it exceptional. It was their job. They did it to the best of their ability because that's what the situation required. Then they went home, returned to their previous lives, and quietly carried the knowledge that they had built weapons that changed history. The B-24s they built flew 226,000 combat missions, dropped 452,508 tons of bombs on enemy targets, destroyed German industrial capacity, crippled transportation networks, and eventually made continued resistance impossible. But the true victory wasn't measured in bombs dropped or targets destroyed. The true victory was that a nation of farmers and mechanics could transform themselves into precision manufacturers in less time than it took to train a bomber crew, could build complex aircraft faster than experienced aircraft workers thought possible, could maintain quality standards that exceeded peacetime manufacturing while working at wartime pace. German factories, staffed by experienced engineers and skilled workers, couldn't match it. Japanese industry, reorganized for total war production, couldn't approach it. Only America, with its vast agricultural workforce that understood machinery, precision, and hard work, could achieve production on such a scale. The assembly line at Willow Run is gone, demolished and forgotten. The workers who staffed it are nearly all dead, their contribution unremembered except for family members and historians. The bombers they built are scrap metal, all but a handful destroyed or scrapped after the war. But the lesson remains. American industrial strength isn't factories or machines. It's people who can learn anything, build anything, and achieve anything when the purpose is clear and the stakes are high. They'd never touched a plane before Pearl Harbor. By war's end, they'd built 18,482 of them, once every hour, with rivets driven by farm girls from Michigan. And the precision of people who understood that doing it right meant bringing someone's son or brother or father home alive. The farmers who built the bombers that won the war didn't ask for recognition. They just built them right, one rivet at a time, until victory was inevitable. The thunder of their rivet guns has faded into silence, but their work reshaped the world.